Franziska is responsible for cross-disciplinary tasks around the development of the digital collection here at the museum.
I'm going to talk about one use case, how collection management can benefit from AI-based processes and vice versa. The MFN holds approximately 30 million objects in its collection, and we estimate that half of them are insects. And here you can see an example draw with bees, and on the left-hand side you can see a multitude of very, very tiny little paper cards attached to the needle. And those contain all the information that is crucial when you want to work scientifically with the collection. So we have here information about the place and date of the gathering. We have determination data. We have other information like the type status. And most of this data is not yet available digitally, which means that we have a lot of steps to come to that information. We need to find out if a specimen is present in the collection. Then we have to go to the cabinet, then take out the drawer, take out the needle, get the images or get the labels of the needle. And to save all these, we decided to start making pictures of these labels. So we have pictures where all the labels are photographed, and that saves us the way to the cabinet and to go physically to the objects. And then we can go on getting the data from these photos to the database. And of course, this is a process where we thought it must be possible to use AI to make that easier. So how did we do that? Before I go into details about our project, I wanted to show you our perspective, because we are working now on transforming our collection into an open digital knowledge infrastructure. And this is how we imagine our data flows in the future. Some of these are already working. And when we look at the project I'm talking about, we are pretty much at the beginning here, like between the first and the second panel of this diagrams. To start the project at all, we needed first the pictures of the labels I was showing earlier. And therefore, we had a large digitization project some years ago in the exhibition area. Some of you might have visited it. That was in cooperation with the Dutch company Picture. They set up a conveyor belt in the exhibition space where we digitized 500,000 specimens from the Hymenoptera collection. And all of them were put on these little black sticks here and were then photographed. And what was important for us, on the right picture, you can see that all the labels were taken off the needle and put on these little black spaces, and a picture was taken from front and also from the back, because sometimes on the back side there's also information. And that was like the data set which we could use to explore how AI could help us getting the data into the database. At the end of this project, we had images, stacked images of the specimen, and a basic set of metadata, which was not on the level of the individual specimen, but on the drawer level, meaning we have some basic information on the taxon and the storage. And most important, we have the images of the labels, which we can use for further exploring. The steps text recognition and semantic parsing are the most important ones, because we want to have the text from the picture of the label machine readable. Therefore, we need some OCR or handwritten text recognition models recognizing it. And then we need to assign information categories to strings in this verbatim text. So we need to apply named entity recognition to this text. From the collection management perspective, it was important to find out what information is most recent on the labels and which categories are suitable to describe the collection best, or to have a good basis of a digital catalog to use it for scientific purposes. So we determined these 10 categories, which we used for the named entity recognition. And those are the categories that would be transferred later to the collection management system. And then at the left of this little table, you can see verbatim total. And this is important because when we do the named entity recognition, we might miss some of the characters that are on the labels. So we always add the complete transcript of all the characters from all the labels to make it possible to have more context. And also the images of the labels will be attached to the data sets later in the database. So you can always compare the transcript with the photographs to see if there were any mistakes. And verbatim is also important because we want to avoid any misinterpretation. So everything is transcribed as it is, even if there's typos or something like that. This is how the transcripts look like when they are ready. We decided to use a structured XML format, which is machine readable. So we can use scripts to transfer that to our database, but also to process that in other machine-based processes. And here you can see that we have a verbatim transcript and the information categories are tagged to them. So we cooperated also with the Austrian company ReadCorp that operates the Transkribus platform for transcription. And here's just an example of how you could distribute in a collaboration project the area of tasks between the different project partners. The images of labels that we have seen earlier were all very nice and neat, but when we look deeper into the collection of labels, we will see a lot of edge cases, which are really challenging for any kind of text recognition model. So here are some examples. You can see we have a large mixture of different handwritings and of fonts and even of alphabets. So we have Cyrillic, we have some Asian alphabets. The orientation of the text lines is sometimes differing even on one label. And then we also have the problem that some of the pictures are upside down, where we also needed to apply a rotation model. Sometimes the readability is really poor. We have ink corrosion, we have fading, we have overwriting, we have damaged labels. But the most important thing is the lack of context, because when you look at images as documents, it's very hard for any model to understand what is written on them because there is no context. And that's one point we really learned when looking at them with AI eyes. So in the example project I'm talking about, we used the Transkribus interface to make quality checks, meaning that after a model did the recognition, the MFN team made some quality checks on sample data. And we very quickly understood that the models used in the Transkribus platform were not specialized enough and had problems with this contextless documents to come to a good recognition quality. So we tried another model, which was out of the Transkribus universe. And we also decided that we would need much more training data, because at the beginning, the ReadCorp did some 6,000 transcripts from written and also printed text. But then we started to transcribe 5,000 only handwritten labels, and that was done by our team, those who have excellent knowledge of the collection, because only them could really check the plausibility of the transcripts, like for the specialized terms, for collectors' names, and for ambiguous location names, because you really have to know the collection to make sure that there is no misinterpretation. Having done that, we retrained the model, but for the handwritten labels, we never reached a recognition quality better than 12.3%. In this case, only half of the pages had 0 errors in the recognition. For mixed labels and printed text, it was much better. So for printed, for example, we had a character error rate of 1.8%. We are going to use the data in our collection management system, which is specifies 7, and we will flag the data as machine generated so that when there's further use, we always know that we have to have a second look at that and not just use it as is. I just wanted to mention our most important learning, the context, because to really make use of AI for collection management, in my view, we really need to have domain-specific models that are pre-trained using norm data from authority records. And there we have the thing that many knowledge sources or knowledge bases are not yet digitally available, but it's knowledge that is available in the collection, but not digitized and in shared platforms. So if you're working in natural history collections, it's really good to use knowledge bases, linked open data systems like Wikidata or Catalog of Life or whatever, to get a lot of knowledge in the internet, because only then we can have the context that the models are able to understand what is written on the labels, so we can have good data for digitizing the collections. And that was it. Thank you very much for your attention.